All right, so we're going to be looking at chemical equations and balancing chemical reactions. And this follows a rule called the law of conservation of mass. Okay, that mass cannot be created nor can it be destroyed. So what you come into an equation with is what you have to come out of the equation with, the same number of atoms. Okay, in chemical reactions, the original substance, reactants, are changed into new substances in products. Okay, and we can see this when we add hydrogen and oxygen together to create water. Okay, this involves breaking bonds and forming new ones. Okay, during a chemical reaction, atoms are not created or destroyed like I mentioned earlier. They're actually rearranged. Okay, so you can't just all of a sudden throw in the in here. You can't just say, oh, we need more hydrogen and throw in more hydrogen. What starts with hydrogen here has to have the exact same amount of hydrogen in the product side. So these are the reactants. Hydrogen and oxygen are the reactants, and water is the product. And you can't again just add atoms of say carbon or whatever inside of this into this reaction. Okay, you can't do that. You have to rearrange the number of atoms that are present here to give you the same number of atoms on this side. And we'll take a look at that. So the total mass of the reactants equals the total mass of the products. And this is called the law of conservation of mass. So each chemical reaction can be expressed in a chemical equation using symbols. Okay, hydrogen, H2, oxygen, O2, equals water, H2O. Okay, these are some symbols that you are going to be using quite a bit throughout the rest of the week. You have pot plus, which means reacts with, so hydrogen reacts with oxygen. You have produces, this is the equal sign almost. Solid is this little s, so there's no solid here. Liquid, liquid state. Okay, aqueous or aqueous state is dissolved in water. There's none here. And then gaseous state is the G, gas and gas. Okay, so these are some symbols that you're going to be looking at and experimenting and playing with for the next, pretty much for the rest of this week. Okay, so when writing a chemical equation, a skeleton equation is done first. Okay, and this is what a skeleton equation would look like. Okay, this states the chemical formulas of all reactants and all products. So for example, when iron and oxygen combine, rust or ferric oxide is produced. Okay, so we have iron plus oxygen equals ferric oxide. So we have iron 3 oxide. Okay, to be consistent with the laws of conservation of mass, chemical equations must be balanced so that each side of the equation has the same number of atoms um, of each element. We can see here that we have, in this particular one, iron oxide, okay, ferric oxide. We can see here that there is one ferric atom here, but there's two ferric atoms here. Or there's one iron atom here, sorry, and there's two iron atoms here. Okay? The law of conservation of mass states that you have to have the same number of atoms on both sides of the equation. Okay? And you can do this by balancing these chemical equations. And we'll learn how to do that. But just know that there's only one ferric acid, there's only one iron atom here, and there's two iron atoms here. So we have to do something to this equation to make sure that there is the same number of iron atoms going into the equation and the same number of iron atoms coming out of the equation. And the same thing rolls with oxygen. You see there's two oxygen atoms here and there's three oxygen atoms right here. Okay, and we need to do something to this equation to make the oxygens equal the same. And this is called balancing chemical equations. Okay, although some chemical reactions have skeleton equation, which is balanced, most require balancing after the fact. Okay, there are a few guidelines for balancing chemical equations. Okay, first is check to make sure all formulas are written correctly. Okay, never change subscripts. Okay, subscripts are these little ones here. Okay, these are the subscripts. You never change these subscripts. Okay, begin with an element that occurs only once on each side of the arrow. Okay, so you see iron starts here, iron is here, so we can start with iron. Okay, And then balance your hydrogen and oxygens last, as they tend to occur more than twice in an equation. Okay, so that will do it for this quick little lesson. I'm going to post another video on examples and how we go about balancing equations. Watch this video and then watch video number 2. I just didn't want to do one really long video. I'd rather do 2 shorter videos. Okay, we'll see you later.